In this video, we are going to see about the histogram processing. So, histogram is an equation that is represented by h of rk is equal to n in n suffix k. So, rk is the intensity value, k is the intensity value, and nk is the number of pixels in the image with that intensity rk. So, if you are considering an 8-bit image, so 8-bit image, the possible number of values, gray level values is from 0 to 255. So why it is 255? It is that 2 power 8 is 256. So we are having the values from 0 to 255 values. So that intensity to is whether it is 0 value or it is 50th value or it is 101th value, that is the RK value, and the number of pixels with 100 gray level intensity and number of pixels with 50 gray level intensity is the NK. So we are relating that H of RK and NK in this manner. The normalization of histogram, so that is the probability density, which is equal to NK divided by M and N. So we all know that M and N is nothing but the size of the matrix or size of the image. So M rows and N columns. So histogram, we can shortly say it is the frequency of occurrence of various gray levels. So how much frequently that particular level, that particular gray level is occurred. So like I said in previous sessions, that is from 0 to 255 values for particular 25th gray level or 20 or 25th or 26th gray level. So how many times the particular intensity is appeared on that image, so that we can get that. So supposing that if more number of zeros appeared in the image, means we can say it is a black image. If no more number of ones up to 55, it is called as it is a pure white image. So the number of occurrences of that particular gray levels will determine the quality of the image. So this is what the histogram works for. So in histogram, the x-axis is gray value and y-axis is the frequency of occurrence of that gray value. Supposing that in the first picture, it is lightly a black and white combination with gray values. So if you see, we have more darker parts. So the histogram graph is on the near to the zero side. So in the second graph, we see that there are more whiter parts and it is more brighter than the previous figure. So the histogram values will be, that is the gray values will be at the 255 255 near 255, and at the third one, it is the it is in between the first image and the second image. First image, it is fully black, and second image, it is little brighter than the first image. But when you compare the third image with the first image, it is better than first image, and it is not up to the mark with the second image. So the histogram values lie in between 0 to 255. So and the second value it is and the fourth figure, it is we are having more histogram equalized images. So we are collecting the values of the pixels, neighboring pixels, and making the equation to be more smarter, and we are having the equations at the last. Histogram equalization. So in this equation, we have a more probability density function. So consider a histogram graph like this from 0 to L minus 1, that is L is nothing but in the gray level. Supposing it is an 8-bit image, it is 255, that is 256 minus 1, that is 255. So if we have a histogram graph like this, we have to normalize the histogram by like this, the right hand side graph. So all in between the 0 to L minus 1. This is histogram equalization, and the condition to be histogram equalization is it's strictly a monotonically increasing function. It should be not like the first graph. It should be strictly increasing function, and the second one is it should be appeared between 0 to L minus 1 values for they represent R values from 0 to L minus 1. So this is the histogram equalized image for the previous images shown. So the first column of the image is the input image, and the second column is the histogram equalized image, and the third column represents the histogram of that particular images. So this is what the histogram works.